Okay, welcome to our environmental insight video. Today we will take a closer look at the water quality of one of Johor Bahru's most critical urban rivers, Sungai Tampoi. Located just 8 kilometers from Johor Bahru city center, Sungai Tampoi winds through a densely developed landscape surrounded by housing areas, commercial centers, and industrial zones. While the river supports urban life, it's also under pressure from it. Along its path, 11 sewage treatment plants, known as WWTBs, are positioned essential for managing wastewater, but potentially harmful when not properly maintained. Over time, these discharge points can contribute significantly to water pollution. The river's health is assessed using Malaysia's Water Quality Index or WQI, which considers key parameters like biological oxygen demand, ammonical nitrogen, suspended solids, pH, chemical oxygen demand, and dissolved oxygen. In our study, we collect data at two stations, one upstream near KPG Puturo Specialist Hospital and another downstream near Tamar Majidi. The results were alarming. WQI values ranged between 35 and 54, placing Sugantambo in Class 4, a severely polluted state. Visual observations revealed murky water, sediment build-up, and minimal signs of biodiversity. The further downstream we went, the worse the water quality became, clearly showing the cumulative impact of urban runoff and influent discharges. This assessment aligns with the broader Clean Johor Initiative, a state effort to rehabilitate polluted rivers like Sungai Tambora, since Sungai Tambora feeds directly into Sungai Tambora. Its recovery is essential for regional water sustainability. In this video, we will walk you through the methodology, key findings, and innovative restoration solutions from composite filters to the total maximum daily load approach designed to restore ecological balance. So, stay with us as we explore how science, engineering, and community involvement can come together to heal Sugan Temple and safeguard Johor's waterways for future generation.
Okay, my name is Bashir, and I will be presenting the methodology section of our water quality assessment project for Sungai Tampoi. This part is crucial as it outlines how we collected data, where it was collected from, and how we calculated the Water Quality Index or WQI, which is a core indicator of river health in Malaysia. To represent the condition of Sungai Tampoi accurately, we selected two strategic sampling stations, namely Station 1 and 2. Station 1 located at upstream near KBJ Buteri Specialist Hospital. Um, this site was chosen due to safe access and less urban influence. Station 2 located downstream near Shell, Taman Majidi. So this spot helps capture the river condition after passing through urban and industrial zones. And these 2 points allow us to assess how water quality changes from the source to the outlet. Now, coming to water quality index of Sungai Tampoi. The water quality index was calculated using the six critical parameters, which are dissolved oxygen, biochemical oxygen demand, chemical oxygen demand, ammonical nitrogen, suspended solids, and lastly, pH. Each parameter reflects a different type of pollution or water chemistry issue, such as organic waste, um, nutrients, or acidity or alkalinity of water. WQI is calculated using the general formula, which is 0.22 times SIDO plus 0.19 times SIBOD plus 0.16 SICOD plus 0.15 times SIAN plus 0.16 times SISS plus 0.12 SI times BH, where SI stands for sub-index. Each parameter's value is first converted into sub-index using DOE approved equations, then weighted according to its importance. For example, SIBOD and SICOD and SIAN um, have different equations based on the range for low and high pollution. So we first decide the range, then we will use the suitable or the right equation in order to determine each each value of the parameters. This method ensures that all parameters contribute proportionally to the final WQI score. Here in Table 4, we have data summary. Water samples were collected in January and February 2025 at both stations. From data summary, the key findings are for station 1, which is the upstream, had a water quality index values of 53 in January and 54 in February, while station 2, which is the downstream, had a water quality index values of 35 in January and 36 in February. Basically, these results show clear water quality degradation at downstream, most likely due to sewage discharge, urban runoff, and industrial effluents. According to DOE classification, WQI of Sungai Tampoi is classified as class 4, which is polluted and only suitable for irrigation. Okay, eventually our WQI methodology allows for a comprehensive and scientific evaluation of Sungai Temboi's water quality. The systematic approach from sampling to sub-index calculation reveals a worrying trend pollution that demands urgent attention and remediation. Thank you and stay tuned for the next part of our video.
Greetings everyone. Today we present the findings of our water quality assessment for Sungai Tampoi, a key tributary of Sungai Tebrau in Johor Bahru, Malaysia. Our study, conducted in January and February of 2025, evaluates the river's condition using the WQI Water Quality Index and proposes actionable recommendation to address its pollution. Sungai Tampoi flows through urban areas like Taman Lakinjaya and Taman Majidi, where industrial and residential activities have impacted its water quality. Our results show that Sungai Tampoi is classified as Class 4 or highly polluted, with an average WQI of 44.5 in 2025, consistent with the Department of Environment's 2023 Environmental Report findings of a WQI at 54. We sampled two stations, Station 1 upstream near KPG Putri Specialist Hospital and Station 2 downstream near Taman Majidi. In terms of dissolved oxygen, DO levels were critically low, below 4 mg per liter at station 1 and below 5 mg per liter at station 2, indicating oxygen depletion that threatens aquatic life. In terms of biological oxygen demand and ammoniacal nitrogen, elevated levels, particularly at downstream, points to pollution from multiple sewage treatment plants located along the river. Chemical oxygen demand and total suspended solids were slightly higher downstream, reflecting cumulative discharges and possible urban runoff. On the other hand, pH remained neutral across samples, showing no significant acidity or basicity issues. Visual observations confirmed a densely built environment with sediments deposition and a widened river structure near wastewater treatment plants likely to handle increased runoff. These findings highlight a pollution gradient with downstream areas more impacted due to sewage effluents and urban development. To address Sungai Tampoi's pollution, we propose a multidisciplinary approach. First, deploying recycled activated carbon-based macrocomposites along narrow strips of river can reduce BOD, COD, and ammoniacal nitrogen levels. These have been lab tested and could be placed near upstream areas like Taman Lakinjaya. Next, transforming areas near the river into mini residential parks like at Taman Lakinjaya with cleanup initiatives and educational signage could help to raise awareness and reduce total debris that is found in the river. Moreover, implementation of total maximum daily load (TMDL) framework to regulate pollutant loads, focusing on BOD and ammoniacal nitrogen using models like Qual2K, can be done by enforcers. However, this step requires accurate local data and multiple stakeholder collaboration, including local residents and government agencies. In conclusion, Sungai Tampoi's Class 4 status demands urgent action to restore its ecological health. Urban runoff and sewage treatment plant discharges are key pollution drivers, but targeted interventions like macrocomposites, community cleanups, and TMDL implementation can improve water quality. These efforts support Johor's Clean Johor initiative by 2030, ensuring a healthier river for both the environment and the local community. Thank you.